Let f of x equal 4 if x is less than 5, and 9 minus x if x is greater than or equal to 5. And let capital G of x equal the integral from 2 to x of little f of t dt. Part A, calculate g of 2 and g of 7. There's a hint, which we're not going to look at until we actually need it. So let's start with g of 2. So just plugging 2 in for x right here. So I'm going to copy that whole formula from 2 to 2 now instead of x at the top. Copy the whole f of t dt. And in this case, it makes no difference at all what the particular function little f is. The integral from 2 to 2 of any function is 0. So that one's easy. All right, maybe the other one will be just as easy. G of 7. This is the integral from 2 to x. So now it's from 2 to 7 of little f of t dt. And here is where we actually need to graph the function because we're interested in the area underneath that little f curve between x equals 2 and x equals 7. So let's graph the function. Okay, so the rules change right here at 5. And on the one hand, it's up there at 4. So I guess up until x equals 5, this graph is always the constant 4. And then after that, it's the function 9 minus x, which is linear. And I'm just going to plot 2 points in order to play connect the dots with this particular function. So for example, if I were to find over here f of 5 and f of, I don't know, 8, just picking any two numbers that are 5 or greater. So we're going to plug in 5 for x right here. 9 minus 5 is 4. And then we're going to find f of 8. So we're going to plug 8 for that x right there. 9 minus 8 is 1. And so we're going to plot these 2 points, 5, 4. Oh, that actually fills in the dot. That was kind of a coincidence. And then 8, 1. So let's put that one over here somewhere. So that's at 8, and this is at 1. Those numbers aren't super important, but we just needed 2 points so we could draw the line. And so this line goes forever after x equals 5. Okay, and we're interested in the area underneath that function we just graphed between 2 and 7. So we'll put some marks here. We've got 2, and we've got 7. And so it's the area of this shape right here. And so I think it's natural to break that up into 2 pieces. So we'll draw this purple line right here where the rules change. And to the left of that line, I have a rectangle, and to the right of that line, I have a trapezoid. So we're just going to add the areas of those 2 shapes together. So the rectangle, base times height, the base is 3. The height is 4, so that's going to be a 12 there. And then for the trapezoid, so I'll go plus here. So the trapezoid formula is half the height. So the height in this case is this right here. This trapezoid is kind of on its side. So the height is 2. And then we're supposed to multiply that by the sum of the bases, and the bases are the parallel sides. This base I already know is 4, but this one I don't know yet, and I need to find it. So how do we find it? Well, we plug 7 into the original function. Plug 7 in for x right there, and we find that 9 minus 7 is 2. So this point right here must have been 7, 2, which means that the length of that base right there is 2. Okay, so now it's just arithmetic. 12 plus 6 is 18. Okay, part B says calculate g prime of 2 and g prime of 7. Let's try it. G prime of 2 equals. Okay, actually before we do g prime of 2, let's do g prime of x. So we're looking for the derivative of this thing right here. So I'm going to write it in maybe a slightly different way. So g prime just really means find the derivative of, and in this case, the function is given by that integral up there, integral from 2 to x of f of t dt. This is me just rewriting, instead of the g function, I've written it out, and then instead of the prime, I put b dx, because in this form, I know that this is our fundamental theorem of calculus part 2. And I know that that theorem tells me that it doesn't matter the number at the bottom of the integral sign. It's a 2 here. That doesn't matter. What matters is that I change the t inside of the function to the variable that's at the top of the integral. So g prime of x is simply f of x. And so that makes this problem trivial now. G prime of 2 is really little f of 2. And according to the definition of f, f of anything less than 5 is 4. So f of 2 is 4. And that's our answer there. And then G prime of 7 is little f of 7, which we've calculated already, but we're plugging 7 in, so we plug it into the bottom rule. 9 minus 7 is 2.